Ampere Circuital Law. The line integral of magnetic field. The line integral of magnetic field induction. Magnetic field induction, that is vector B, around a closed path. Around any closed path in vacuum is equal to mu 0 times, where mu 0 is the magnetic permeability of free space, is equal to mu 0 times the total current, is equal to mu 0 times the total current threading the closed path. The line integral of magnetic field induction around any closed path in vacuum is equal to mu 0 times the total current threading the closed path. That is, line integration vector B dot vector dl equal mu 0 I. Line integration vector B dot vector dl is equal mu 0 I. Now we can consider a straight conductor or long straight conductor through which a current I is flowing or passing, and around that straight conductor we can consider a circular closed path. Around that current I or the long straight conductor we can consider a circular closed path. This is the circular closed path. This is the closed path around a long straight conductor, or this is a circular closed path through which the current I is threading at right angle. And we can consider a point P on this circular closed path. We can consider a point P on this circular closed path, and there are 2 points AC. There are 2 points AC, and length of this small element AC of this closed circular path is dl. dl is the length of the small portion AC containing the point P on this closed path, and the small length vector, that means vector dl, acts tangentially on this circular closed path, and this vector dl is also acting inwards with respect to this plane. Now magnetic field induction at the point P due to the current I is vector B, and that magnetic field vector B acts inwards at the point P. That's why it is denoted under bracket across, and vector B dot dl, closed integration vector B dot dl is equal to mu 0 dot I, mu 0 times of current I. So this is Ampere Circuital Law, vector B dot vector dl. If we do dot product, if we do integration, line integration of vector B and vector dl, then we get mu 0 times of current I, mu 0 times of current I. And this is Ampere Circuital Law. That means integration vector B dot vector dl is equal to mu 0 times of the current I, and the surrounding medium of the long straight conductor XY is vacuum. And here what we can consider, let dl be the length. Let dl be the length of the small portion or small element AC on this circular closed path. Let dl be the length of the small element A1, C1 or AC of a closed circular path. It should be AC, not A1, C1. dl be the length of the small element AC of a closed circular path through which a current I is threading, at right angle or perpendicularly. And vector dl acts tangentially. Vector dl acts tangentially at the point P on this circular closed path. Vector dl means small length vector acts tangentially at the point P on this circular closed path. Vector dl acts tangentially and inwards at the point P on this circular closed path. And vector B is a magnetic field induction vector. Vector B is a magnetic field induction vector at the point P due to the current flowing through the long straight conductor or a straight conductor. Vector B is the magnetic field induction vector at P due to the current I, which is threading the closed circular path, Current I is threading the closed circular path perpendicularly, and it also acts inwards at the point P. That means this magnetic field B acts tangentially to the closed circular path through which current is threading, and it also acts inwards at the point P. Again, we can explain here, this is the closed circular path or circular closed path around the current I. This current I is threading at right angle to the closed path, and we consider a point P, and also we can consider a small element A1C1. And this small element A1C1 has the length dl. At the point P, length vector, that means vector dl, acts tangentially to the circular closed path and it acts inwards. Similarly, the magnetic field induction at the point P due to the current I is vector B. And this magnetic field induction at the point P due to the current I is vector B, which acts inwards. That means vector B is parallel to vector dl according to Ampere Circuital Law. According to Ampere Circuital Law, closed integration or line integration vector B dot vector dl is equal to mu0 times of current, where mu0 is the permeability of the free space or magnetic permeability of the free space. Closed integration vector B dot dl is equal to mu0 I. Now we consider a closed circular path or circular closed path. We consider a closed circular path through which two currents I and IR will be flowing, and this is the closed circular path. Through which a current I is threading or is crossing, and we can consider another current having same magnitude, that is another current I is also flowing through this circular closed path, and here we can consider a point P. At the point P, length vector of a small element is vector dl, which acts tangentially and inwards, and dl is the length of the small element on this circular closed path, and we can consider a magnetic field, that is vector B, acts due to this flow of current. In this case, vector B dot dl, closed integration vector B dot dl will be equal to mu0 times, where the surrounding medium is vacuum. In this case, closed integration vector B dot dl should be mu0 under bracket 2I, because there are two currents which are threading through the circular closed path. So this is also Ampere Circuital Law, or a mathematical expression of Ampere Circuital Law, in which two currents I plus I, that means 2I, is the current which is threading through the closed circular path.